Hello friends, in today's question, three disks A, B and C having radii 2 meter, 4 meter and 6 meters respectively are coated with carbon black on their outer surfaces. The wavelengths corresponding to maximum intensity are 300 nanometer, 400 nanometer and 500 nanometer respectively. The power radiated by them are QA, QB and QC respectively. Then we have to find out what will be our QA, QB and QC, or relation between QB, QA and QC. So in this case, we are going to use two standard laws. One is called as Stefan-Boltzmann law and another one is called as a Wien's displacement law. Okay. So let us start with Stefan-Boltzmann law. So Stefan-Boltzmann law, it gives us a relationship between the power radiated, surface area as well as the temperature. So it gives us that Q is equal to a T raised to power 4, where Q is the power radiated, A is the surface area, and T is the temperature. And the sigma is the constant, Stefan constant. Stefan-Boltzmann constant. A is the surface area, so we have three bodies, so we can accordingly, and they are having no different, they are having different radii. So A is our surface area, so therefore we can write that our A1, AA rather, will be, it can be written as pi RA square, which gives us radius of A is given as 2 meter, so this comes as 4 pi, and similarly we can write for our B body, area, surface area of B will be equal to pi RB square, and this comes as 16 pi, and we have surface area of body C, which is pi RC square, and this comes as RC is given as 6, so this comes as 36 pi. So therefore we can write the ratios of their respective surface areas. We can say surface area of A ratio surface area of B ratio surface area of C, it can be written as 4:16:36, and which can further written as 1:4:9. Now we are going to use Wien's displacement law. And the Wien's displacement law gives us the relationship between the maximum wavelength and the temperature, and this gives us that lambda max multiplied by T is equal to B. So from here we can write that our temperature T is inversely proportional to lambda max. So once again we can divide this particular equation into three bodies. We can write that for TA it will be 1 upon lambda A, TB once again 1 upon lambda B, and we have TC which is also 1 upon lambda C. Here lambda A, lambda B and lambda C are the maximum. Okay, for the ease of convenience I have not written here max. Lambda A, lambda B and lambda C are given to us. So therefore we can write that the ratios of temperature TA to TB to TC will be equal to 1 upon lambda A, 1 upon lambda B, 1 upon lambda C. We substitute the values. This comes as 1 under 300, 1 upon 300 ratio 1 upon 400, and this will be equal to 1 upon 500. In the simplest form it can be written as 5 is to 3.75 is to 3, and because the relationship which is required is to our fourth power based on the Boltzmann law, so we find out the fourth power of this ratio. So from here we can write that TA raised to power 4, TB raised to power 4 and TC raised to power 4 will be equal to 5 raised to power 4, 3.75 raised to power 4 as well as 3 raised to power 4. And this further solution gives us 625 is to 198.14, and last one will be our 81. Now we are going to make a radiated power comparison, that the ratio of QA, QB and QC. So we can say a radiated power comparison. So we can write that our QA is to QB is to QC will be equal to area of A multiplied by temperature of for A. So this becomes area of A, temperature of A raised to power 4 is to area of B multiplied by temperature of B raised to power 4, and we have area of C multiplied by temperature of C raised to power 4. We simply substitute the values and we get this as 1 multiplied by 625 is to, we have this as 4 into 198.1 is to 9 into 81, and this gives us equal to 625 ratio 792.56 is to 729. So therefore we can say that our QB is greater than QC is greater than QA. So it means QB will be maximum, because in the option I think it is written like that only. Yeah, QB is maximum. QB radiates maximum power. So the options, option number B is the correct option. Option B is correct. So this completes the question. Thank you.